one set. Is a four faces belong to one set. The eight edges of the same length formed by the intersection of eight faces belongs to the second set. In case of four faces is a one set, eight faces is a second set. The a face of one form and a face of other form belongs to the third set. This is a one set. Four faces. This is only four faces. So it's a one set. Whereas a two sets, if you got in two set image, this image is blurred actually. You can see, observe here, there are crystal forms of two faced forms, two frames. Okay. Whereas a crystal has a four faced, 1, 2, 3, 4, like this. But here is the image is showing the only one face. It's only one face, one side you are seeing. So for that one, we're calling as a one face. Already we know the faces. What is a face? Face is nothing but external expressions of the internal atomic planes. External expression of the internal atomic planes. So where you can call it with the corners. Yes, the corners also important. One crystal has the edges. So how many corners? A corner is a point without any dimension. It is also called as a solid angle. It is formed by the intersection of the three or more faces or three or more edges. The number of corners of a crystal is obtained by this equation E plus 2 minus F. E plus 2 minus F. F is nothing but faces, E is nothing but edges. Where total number of faces belongs to all forms. The crystal shown in figure 1.3. 1.3 you can see here. 1.2 here. Here you can observe. There's a two-faced form. Okay. And how many edges? 20 edges is plus 2 minus 12. 12 faces. There's a 12 faces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, sorry. 1, 2, 3, 4. So whereas a 4 is showing here, 5, 6, 7, 8, 9, 10, 11, 12, 8 is showing the one phase. This is a one phase. This is a two phase. Second phase. This is a third phase. This is a fourth phase. So 5, 6, 7, this is 8, whereas a 9, 10, 11, 12. These are 12 phases. It consists of 20 edges. So the corners of the crystals belongs to one or more set corners formed by same number and same type of faces. It's a corners. One corner consists of three faces. One corner consists of three faces. 1, 2 faces. There is some corners has the one is a one face. This is two face. This is three faces. Like this. These corners are the corners. There is a center of crystals. In calling a there is a formation of the crystals. There is a, if in case there is a closed form, we have that assemblies of faces which can enclose a volume of space. How the faces will come if in case you have the for clarification, if in case combination form, when a crystal is made up of two or more simple forms, such as when it is consists of basal, pinacoid, and prism faces. It is a simple form. We call it a simple form. When it's an open form, in the open form, these forms, open form like is not, faces cannot enclose spaces all by themselves, as they do not have adequate number. Faces to do and results occur only in a combination with other forms such as pinacoids and prisms. There are types of prisms. We can when you're going to inside, there is a we'll know about prisms and all the things. All the prisms will there. We will discuss on this. We'll discuss about this all the crystals and prisms, and whereas what is angles, what are that elements of symmetry, what, how the elements faces edges is we're calling, right? What is which element of symmetry, what is a crystal symmetry. We will discuss on all the things here up in the upcoming classes. So this is a basic information how the axis of crystals, center of what is the axis of crystals, what is a crystal, corners of crystals, and edges of crystal, face of crystals, edges of crystals. What is the edges of crystal? What is the face of crystal? If you know that this crystals formation, then you can easily identify all the things. What is the crystals, and you can understand about the crystals. There are, first you have to know the crystallography. Crystallography is nothing but study of atomic and molecular structure. We're studying about the atomic and molecular structures. Like examples of minerals, if you want any minerals such as a quartz, diamond, and graphite, these are minerals. Crystalline solids such as minerals, various potential differences there. Coming to crystals, it is regularly polyhedral forms, solid. Crystal like a solid only. Never ever is not liquid. So crystal is nothing but solid material. It's bounded by smooth faces. When you touch in any way, is having the smooth faces. Faces is nothing but, as we discussed earlier, face is nothing but external expression of the internal atomic planes. That is the faces. There is a defined chemical compound. Like a atomic forces, interatomic forces of the anions and cations will form the most stable configuration based upon electron configurations. With that only, crystal will form. There is a solid phases. If in case one crystal having the there is a chemical bonding is there about anions and cations, how many anions are there, how many cations are there. Based on that one, the crystal will form. There is a strong crystals having the bonding section will not remove any electrons and protons from that crystal. Usually this forms while it is changed from a liquid gas in a solution to a solid. These are changes from the liquid and gas state. Sharing the all anions and cations, then it will form as the crystals. There is a when you're talking about crystals, you can see, observe the image. Is an external form as well as the internal atomic structure is said to be a perfect crystal. Okay, but if it is possesses only the internal atomic structure, if in case it's the internal atomic structure without the development of corresponding external form, it's said to be crystalline. When there is neither internal atomic structure nor external form, it will be known as an amorphous substance. These are all three crystals general characters. Crystal is the general characters with these main basic things. What is that? Another thing is a geometry is developed only under suitable physicochemical conditions. Like these crystals are forms only slow cooling. Crystals are forming in the slow cooling with the under physicochemical conditions, suitable physicochemical conditions. Then only crystals are formed. Okay, we will discuss about all the elements of crystals tomorrow. Actually, we will join the late. So, elements of symmetry. There is another topic. The center of symmetry. Here you can see center of symmetry, center of crystals as well, center of symmetry, axis of crystals. You can all calling it the symmetry of elements. Crystal symmetry, crystal center of symmetry, crystal axis of symmetry. There is another is there plane of symmetry, pseudo symmetry. There are 4 types of that. Center of symmetry. And actually, you can carry what is symmetry first to get the doubt. For that one, crystals also show certain regularity of position of faces. Crystals showing the regularity of positions. See the image. Where is the image? It's the only one image. Edges, corners, corners, solid angles. These are all geometric locus. The group of repeating operations known as a symmetry of elements. All calling symmetry of elements. With respect to point, which case center of symmetry. Sometimes with respect to a line, which case as an axis of symmetry, center of symmetry, angle of symmetry, or when the repetition is the respective plane of plane. It's a one side plane, the plane of symmetry, you can call it. Okay, tomorrow we'll discuss about the center of symmetry, axis of symmetry, plane of symmetry, and pseudo of symmetry. Then we can going to discuss about the laws of crystallography as well as the type of crystals, crystal systems and classes. There is a 6 crystals and 6 classes are there. In the next class, we'll discussing on that crystal symmetry and crystal classes. Like 6 classes are there: isometric, called like isometric, tetragonal system, hexagonal system, orthorhombic system, monoclinic system. Yeah, there's a 1 class is there. In the between, there is so many crystals are there, triclinic system like that. There's an what is a how many there is a systems. There is a different classes. Each system has a different classes based on the system access. We can divide the classes. So before that, we have to know the access, how the access is following. What is the center of crystals? What is the faces? How can identify the faces, edges, and corners? These 4 objects which making the solid of the crystal. As you say, would see these are important parts: faces, edges, corners, centers, axes, zones, planes. In the 6 elements only, crystal will form. With these elements, where there are divided based on the elements, they are divided into so many 6 crystal symmetry was divided. We will discuss on the later classes. Thank you, all of you. Yeah, bye.